All right, so we're going to get started here. Looks like it's right at 10 o'clock. I want to thank everybody for joining us in this week's iteration of the Long Coffee Break. My name is Jordan Weiss. I will be hosting this week. Today we have a special guest with us today. It is Aaron Levy. He is with QPAC down in Florida. We're going to go over ECM fan arrays. And without further ado, I'm going to shoot it over to Aaron. He's going to kind of get you up to speed on this product.
All right. Good morning, everyone. Like I said, my name is Aaron Levy. I am the regional sales manager for QPAC. We are a fan array company that does custom solutions. Let's see if I can get my. When we talk about fan array systems, you guys are very probably familiar with this. You've probably heard it either called like fan walls or fan cubes and different things like that. What we do is we create a custom solution for just about any application. We really like the retrofit side market. It helps with customer lowering their energy costs. Some places give tax credits depending on where you're located. That lowers their maintenance costs for the staff. And it keeps from having any interruptions in the system. In a lot of ways, we can actually make an entire building pretty cohesive by having maybe 1 to 2 part numbers through the entire building versus having multiple fan motors, different pulleys, different solutions. So when we talk about QPAC, we are a one-piece solution. We provide you pretty much everything you need to install the system. That includes the custom bulkhead. So what we ask is you measure floor to ceiling, wall to wall, CFM, static pressure, voltage, and then we can build a space for that. The bulkhead comes in hand carryable pieces. We also provide you with the motors themselves, all the wiring harnesses that go with it, all the controls, the outdoor display and main disconnect, as well as the quick connect box or boxes inside, depending on the number of fans. What really makes it easy is about 2 to 3 people can install this system in a matter of hours versus something like a cube system. Everything's hand carryable. Everything gets through standard size doorways. The heaviest component of the system tends to be the fans, and the maximum weight on those fans tend to be about 100 pounds, 150 pounds at most. We designed a system so that it can be carried through service elevators, hallways, and by 1 or 2 people. The only thing that's not included in our scope is the power and communication conduit between the fan, the main disconnect outside and the quick connect box inside, as we don't know where that controller is going to be mounted. So it's minimal work for an electrician to come to the job site and make those connections for power and communication. A lot of the differences from currently what may be in there with either a belt drive or direct drive system versus an EC fan array is that the EC fans all have their integrated controls. They're very similar to a VFD and the fact that it controls the speed. It just goes about it a different way. So instead of controlling the Hertz profile and changing that speed through the sine wave, we change it just from how we control the flow of voltage going into the fan itself. The Hertz profile always stays 60. The voltage always stays at mainline voltage be at 460, 230, 208, 3-phase. And it just controls the pulse of that voltage going to the stator itself. So there's no additional heat load, no eddy currents, no destructive phases going through that fan. There are no additional wheels, pulleys, or hubs that you have to do. Mainly like with the direct drive, you're buying a motor from Baldor Marathon or something like that, a wheel from one manufacturer, a hub from another, and all of that stuff is not balanced as a whole. Whereas the EC fan is built as one complete piece. The motor, the impeller, all that stuff's mounted together and then balanced from the factory. Therefore, it can be rigidly mounted via AMCA. So there's no additional vibration rails, there's no cork insulation, no spring isolators, and no other losses that you would get from that. Again, there's no maintenance, there's no bearings to grease, as everything's a sealed system. So it really takes something out of play for the maintenance people to have to come in there and have to service those belts, service those bearings on the regular. It's also a lot faster to change these things out in the field. It takes about anywhere from 10 to 20 minutes to change the fan out. It's about 8 or 9 bolts, disconnect a couple of Molex plugs and the pressure tubing. You pull it off the wall, You put another one back up, bolt it up in its place, and then plug those back in. And then the system can be up and running relatively quickly without a lot of downtime for the customer, as well as integrated redundancy. If you lose a belt, you've got nothing. If a motor burns up, you've got nothing on a belt drive system until you can have that replaced. Direct drive systems for cubes and things like that, there are some limited redundancy because they'll use bigger motors, anywhere from 2 to 4, and you could lose 0.25% of your airflow. For the QPAC style system, we integrate a lot of that redundancy, so it's almost N+1 for a lot of cases, where if a fan goes down, you can spool the rest of them. The rest of them will spool up automatically to compensate for that fan, and the customer never feels that even interruption in their system. And we normally talk about like total fan efficiency for systems versus like motor efficiency. Um, so belt drives at best are probably anywhere from 15 to 35% of total fan efficiency. Direct drives 20 to 42, and then EC fans can be anywhere from 35 to 70%, depending where it operates on the curve. So that payback for that customer is a lot faster in the grand scheme of it. And then when we talked about like motor efficiency, uh, those motors like Baldor Marathons, those Super E's and things like that, they tend to be anywhere from like 88 to 92% at full load. Partial loads and slowing them down, you start to see the fall off pretty quickly. EC fans don't tend to have as much fall off until you get about 20% under their RPM speed. Then you start seeing it. But once you start adding a VFD and belts and pulleys, all those losses still come down. The fans are also a lot quieter, and they don't have that vibration that'll vibrate through the chassis. They don't hear the air noise coming back down through the system. So it does make that a lot easier with going to an EC fans type solution. One of the big misconceptions that I get a lot from contractors and things like that, from our competition stuff, is that harmonic distortion from a VFD setup to an EC fan is worse, and it's just not true. In essence, they're both 6-pulse inverters in a way that they deal with the harmonics. There are a few additional filters built into the electronics of an EC fan that give it anywhere from about 10 to 20% better harmonic distortion. But in essence, it's still roughly about the same. Without using an active or a passive filter, harmonic filter in line with it to eliminate it less than 5%, which you would need for both. So in a lot of cases, I tell people, if you currently have a VFD system already on premises, going to an EC fan solution isn't going to make a big difference in the grand scheme of your harmonic distortion. A lot of places like hospitals or data centers, things like that, where it can be critical, they already know they may need that just to eliminate that altogether, and they will buy an active filter to put in line. And we have partnerships with those that can help that we can price into an application if need be. Like I said, with our quick connect wiring, it makes life a lot easier for the installer. And I know we got some mechanical contractors here, and this is kind of more geared for what you guys have to do. Once that bulkhead wall is up, which doesn't take very long, all the pieces kind of fit together. They're all labeled in order of where they should be going. At that point, you can put any fan in any slot, and then each wiring harness is provided that'll go to each individual fan location. So the box to the left side of this is what we call our quick connect box. It's the power and distribution hub. And then we give you cable routing for how each one of those wiring harnesses will connect to that fan. And they'll all be labeled 1 through, in this case, 1 through 8. And then you'll know which one goes to which fan. But it makes life a lot easier that you guys don't have to pre-run or cut your own wire or run it on yourself. And it just, those stay in place. They're already pre-mounted and pre-drilled slots for all of those. We provide even the zip ties and the screws to put all this thing together. Short of coming up with a 5/16 drill bit for the self tappers and a 1/2-inch drill bit for putting the fans on, that's really about all a person needs to install this system. So we talk about our competition and what you may face out in the field or what we may be competing against directly. These are kind of the systems that you would see, where each fan will have its own drive. What I talk about with customers, end users, even mechanical contractors, is that this system that we're competing against has motors that can weigh anywhere from 200 to 1,000 pounds. You're going to need gantry systems. You're going to need rigging equipment. It takes a lot longer to install those because you have to sometimes disassemble those cubes to get them into the space, then reassemble them later, versus just being able to carry everything into an airspace, putting it all together in one big motion, and being done in a day. There's no programming that needs to be done. We've taken that all into account on our side. Therefore, it cuts down on a lot of your electrician's labor hours, as well as programming. Labor time is the biggest savings that you can get for getting jobs done. Normally, the demolition takes longer of the old unit than it is to install our system. We provide you a 5-year warranty on all the components. That includes controllers, fans, bulkhead wall, wiring harnesses. So anytime something like that fails, we keep everything in stock in Jacksonville, Florida. All the indoor components, all the fans, we have a spare stock just for replacements. That way, sometimes the customer doesn't really need it on site to have a spare fan. We've designed the system so that if a fan were to fail or a component fails, there are backups. That doesn't make everything the world stop. It doesn't make everything as critical. You can take your time. You're not panicking. You're like, okay, I can just order a fan. It'll be here in a couple of days, and then we'll replace it. In most cases, a customer won't even know a fan's down without the alarm screaming at them. So, and then most of the time, they can kind of set a shutdown over lunch hour or schedule a breakdown at the end of the day to make those changes and to be ready to go the next day. We offer 2 sets of controls, basic and premium. 95% of the jobs we sell are premium controls because of the backnet capability, the 0 to 10 modulation, which is also the same for basic controller. But you get individual fan statuses, safety and interlock capabilities for start stop. You get airflow and power monitoring, a touchscreen digital display, energy consumption modes. So you can check in every little component of that system. It'll also allow you to run it at constant volume or constant pressure, depending on how the system is designed. We give you pressure transducers on a premium controller. There's a high side port into the quick connect box and a low side port on the fans, and that'll read out static pressure to the system. And most of the people will run that in what they call an open loop scenario, where if a fan fails, the other fans will spool up and compensate for it. You get a local alarm. There's a hand auto and off switch on each controller, as well as a pot. So in most cases, when these jobs are being installed for the first time over a weekend or something like that, the building management side or the control side is not even ready to land their stuff yet. The electrician and the installers will have that system ready to go, wired up, and then they can run it in hand mode once they got power line coming to it, and then control the fan speed with the potentiometer that's located on there, and then they're done until BMS comes and lands their stuff on the controller to run it in auto mode. So it makes life a lot easier. If something ever goes down with a controller or the BMS, you can always switch it to hand mode and drive the fans that way. And this is just what we call FS1. Is kind of our newer system that evolution. We have now designed and built everything in-house. Everything from the controllers, the quick connect box, and the bulkheads. The only thing that we don't build ourselves as QPAC is the fans, which we buy from German suppliers. But we have, at any point, 3,000 fans in inventory right now, with another 10,000 fans coming in the next 3 to 4 months. So we have tons of inventory. Our lead time tends to be somewhere around 3 to 6 weeks, 3 to 5 in a lot of cases. So like I said, we have all those parts available. So it's not a big worry about trying to find that stuff or having a long lead time on getting replacement parts. In a lot of cases, there's nothing inside those controllers that you cannot get off the shelf at a local supply house or an equivalent to one of those things. So you're not scrambling to find a proprietary part. As you can see, all the wiring harnesses and how they're run, all of that stays in place once it's installed, and then you make all your disconnects at the fan themselves. Right on the fan tray, you can't really see it from this side, but the wiring whip that comes out of that electronic motor plugs right onto the fan tray, so you just disconnect it from there. Really makes the installer's, mechanical contractor's job so much easier to put this thing together and then be ready to go to the next job. So kind of we discussed, we offer also technical support. So we've got a team in-house that also offers our services where we come out to the job site. And I always do recommend this for the first mechanical contractor's job, putting in a QPAC. It's a flat fee when they come out there. They're there to help with install and startup to make sure everything goes smoothly. Once a mechanical contractor and a team have done one of these, the next ones go faster and faster and faster. But we offer that as an available service if need be. It comes with pretty simple, intuitive instructions on how to build it. If you've ever built an IKEA piece of furniture, this is 10 times easier than that. So when we're talking about lower maintenance costs or lower energy demands, typical ROIs for a lot of customers for most HVAC applications that go between like 2 inches of static and maybe 5.5 inches of static, ROIs tend to be somewhere between 12 and 48 months, really depending on what we're removing, where the what the energy cost is, and how many hours it runs per day. But that does tend to be where about 85% of jobs land in that less than 48-month time frame. So I can run energy calculations for a lot of people to kind of give you a ballpark idea of what that energy savings may be. But one of the benefits is that you never really have to change the service of the job. If the current service going to the existing fan is 30 amps, we are typically be less than that. It's at 30 amps or less with added redundancy. We're really only limited by the space of the air handler, not really by CFM or static pressure. Static pressure, we can get up to about 10 inches. Anything more than that, you're really getting in direct drive territory anyway. But we've done systems as big as 60 fans in one array. Vertical markets that we really target a lot are hospitals, universities, arenas, high-rise buildings. Those tend to be our biggest bread and butters. Airports, we've done a lot of too, data centers. But universities and hospitals tend to be the biggest problems because most of their systems were built around, the buildings were built around the equipment. And you've got big belt drive systems and big air handlers that they never really figured out how you're going to get that system out if it ever failed, and how to get a new one back in without having custom parts built. So this is a perfect example of how you can kind of give an old air handler new life and extend it out by saving the customer not just money on the front side, but on the back side as well. Maybe sometimes I've seen people just replace the coils in the air handler and the blower section and get another 10, 15 years of life out of these fans. So kind of really just making it short, one of the other big things I'll talk about and that people ask is about life expectancy of these fans. The L10 for these fans tend to be anywhere from 50,000 to 80,000 hours. That is be about 5.5 to 10 years of what they call the L10 or 10% field failure rates. MBTF, or about 50% failure rate, mean time between failure, is over 100,000 hours. It's very rare for these fans to fail. Typically, if they do, it's very much power related coming into the building. We do have, the fans have a lot of safeties built into them to protect them from over voltage, under voltage, phase loss, phase rotation imbalance. You can't run these fans backwards. So L1, L2, L3 is irrelevant. You can put it on whatever terminal leg you want. You can't run them backwards. The fans correct the phase inside the electronics. Over temperature of the electronics, over temperature of the motor, lock rotor protection for in case a filter or something flies through there. And then inside those quick connect boxes is a fuse disconnect. And then of course you've got the outdoor controller as well. So one of those components are there to protect the fans before they even get hit with anything. So in a lot of cases, we don't tend to see a lot of fan failures. And in the event that we do supply a blank off plate, so you could remove a fan and put a blank off plate there instead of having to use backdraft dampers. So, I mean, it's a very intuitive and easy system. And I'll open it up to any questions. These are all the contact informations for everyone at our company that are the main contacts that you may need. But I open it up to any questions. You can either do it in chat or you can open it up here.
Yeah, so if we got any questions, we can round those up and get those back to the long sales guys.
Yeah.
And we can get those things answered through Aaron. Please join us next week if you guys would. We really are looking forward to having this long coffee break. John Stump is going to be going over refrigerant changeouts. So with the current things that are going on in Colorado with new refrigerants, I'm sure all of our engineers are hearing this. We would love to see you next week. We think it's going to be really vital to go through some of this stuff with you guys and the constant changing environment in Colorado in particular. So I appreciate it, Aaron. Thanks for your time. And join us next week. Like I said, you guys have a great day and hope to hear from you guys soon.
All right. Thank you, everyone. Have a great day.